Welcome or welcome back at C-Square. In this lesson we're going to talk about two-dimensional figure polygons, and we're going to talk about perimeter and area of polygons in this lesson. And you have here an example, three examples in fact of polygons: a plane figure with at least three sides. We have one of three sides, a triangle. We have one of four sides, a quadrilateral, and one of five sides, which is called a pentagon. The perimeter of this polygon is the sum of the lengths of the side of the polygon, and you'll see that in this lesson. And the area is the total space enclosed within the figure. What is inside? You will see that in the lesson. We'll start with the first one, the three sides, the triangle I mentioned before. And you notice here the perimeter is the sum of the sides of this triangle. A plus B plus C. You're going around. You start from one point like this one, going around here, and be back in that point. Okay, that's the perimeter. The area, on the other hand, you see it's what is shaded, what is inside. We have a formula 1/2 times B, which stands for the base, and H stands for the height. You see the base is this B in this case, and the height is the corresponding altitude, we call that, to this B. Okay, you'll see how I'm gonna use this in my next example. So find the area and the perimeter of each triangle and start with A. And let's start with the perimeter. If you remember, the perimeter means the sum of the sides. So let's say you start from this A, you're gonna move to B, right? That will be AB. Then from B, from here, from this point, you're gonna move to C, and then we have the BC. And then we're gonna move back to A, from C to A. We have CA or AC, by the way, you can write it either way. Now, do we know all these things? AB, it's 6.1, we can see it is given right here. BC, it's 5.4, and C8, so this is BC, CA, which is the same with AC, it's 5.6. So as you notice, we don't really need to add, in fact, you don't want to add AD in this expression. So we have 6.1 plus 5.4 plus 5.6, I end up with 17.1. 17.1, let's use the unit centimeter because we have the units. The next thing in this problem will be to find the area. Okay, the area of this triangle, like any other triangle, it's 1/2 times the base times the height. So in this case will be 1/2 times, what will be the base? Since we have this segment AB, that would be the height. We see it's perpendicular on BC. So that will be the base, BC, 5.4. And the height is this AD, I marked it already, 5.1. So let's grab a calculator and do this math. Okay, so I think the easiest way is to do 5.4 times 5.1 and then divide by 2, and I end up with 13.77. Now let's use the units here, square centimeter. Okay, so you notice the units for area are square centimeter, for the perimeter are linear units. Okay, let's go to part B, where we have to find the area and the perimeter of this triangle. This is a special case. It's a right triangle, is on coordinate grid. So the first thing I'm gonna do, I'm gonna count to find the lengths of some segments, and I'm gonna start with AB. 1, 2, 3, 4, 5. This is 5. So it's gonna be this AB, which is 5, plus 1, 2, 3, 4. This is 4. And now we have an issue. We do not know how long this is, but this is a right triangle. We can use Pythagorean theorem or distance formula, and we have here a squared plus b squared equals c squared. In this case, we're going to have 5 squared plus 4 squared equal this c squared. And we're going to have 25. 5 squared is 25. 4 squared is 16 equals c squared. So c squared will be 25 plus 16 is 41. And c, which is nothing else than ac, would be square root of 41. So the exact value of the perimeter is this expression, which you can simplify as 9 plus square root of 41. This is the exact value. But also I'm going to approximate to the nearest tenth, how it says. So for that reason I'm going to need a calculator. Be sure you know how to use a calculator. And I have 9 plus square root of 41, I end up with 15.4. And I'm going to put here units. Okay, we don't have a centimeter, inches, we have just units in this thing. Okay, and the last part of this problem, find the area. I'm gonna move down here. Area is the same formula, 1 over 2 area times the base. Now, since this is a right triangle, so again I'm going to use this formula. This is a right triangle. You can say this is the base for, and this is the height. You can switch this guy and you're gonna get the same answer. So we have 4 times 5 divided by 2, that would be 10. And to be consistent, let's say the units is square units. And that's it for this problem, which involves the polygon of 3 sides, a triangle. Next part of the lesson, we're going to talk about rectangle and square. These are some other polygons, simple two-dimensional figures we have. And this is the formula for the perimeter. You can simplify and say perimeter is twice the length plus twice the width. Then this is the area. Remember, the area is what is inside. This is the area. For a square, we have a special formula. Perimeter equals 4s. We add the 4 sides. And the area, what is inside, is this s squared. So remember these two formula, and you're going to see them. I'm going to use them in my next problem, where we need to find the area and the perimeter of rectangle ABCD, the one on the left, and the square EFGH. So let's start to A, and we're going to start with the perimeter. For that reason, we need to find out how long this side is, and one more, I guess, any 2 sides that are consecutive sides, one after the other one. Okay, for this one, again, I'm going to use Pythagorean theorem. I'm going to use this triangle. This is 1, 2, 3, 4. This is 2, and I'm going to put that mat here. A squared plus b squared, like the previous problem, equals c squared. And we have 4 squared plus 2 squared equals c squared. There will be 16 plus 4 equals c squared, which means c, or AB, or the width, let me put like this. This is the width of the rectangle, is square root of 20. Okay, but what about the length? The length is, let's say, this BC. Again, I'm going to use this form. You see, I have 1, 2, 3 here, and 1, 2, 3, 4, 5, 6. This is 6. So again, a squared plus b squared equals c squared. The only difference, we have 6 and 3 now. 6 squared plus 3 squared equal c squared. It's a different c, let's be sure, than the other c, but since we use Pythagorean theorem, let's use it like this. So we have here 36 plus 9 equals c squared, and c squared will be 45, which means in this case that BC, which is the length, is square root of 45. So now we have everything we need to find the perimeter and the length. Perimeter, I'm sorry, and the area. Okay, so the perimeter will be twice the width plus twice the length. So we are going to have 2 times square root of 20. The square root of 20 is what? 2 square root of 5 plus 2 times square root of 45. That is 9 times 5, so that would be 3 square root of 5. So we have here 6 square root of 5. In fact, let me be consistent. Let's start with 2 times 2, which is 4. 4 square root of 5 plus 6 square root of 5. That will be nothing else than 10 square root of 5 units. Remember, we are in the rectangular grid here, so we're going to use units. An approximation eventually, right? Let's grab a calculator, and I'm going to do 10 times square root of 5, and I end up with 22.4. I round it to the nearest 10, 22.4 units. Okay, let's go to the second problem, the square. The perimeter, if you remember, we have an easy formula here, 4 times s, s being this 8.1. It's going to be 4 times 8.1. So the perimeter will be 32.4. And this is inches. What about the area? The area, if you remember the formula, we just have it on the previous slide, is going to be the side square, and that will be, in this case, 8.1 square, which means (65.61) rounded to the nearest tenth, so that's the 65.6 square inches. And let me go back to A. I think I forgot the area here, right? So back to A, the area, that will be interesting. It's length times width. So in this case, it's gonna be, I will say, let's use this simplified form, 2 square root of 5 times 3 square root of 5. So what is that? That will be 6. 2 times 3 is 6, and square root of 5 times square root of 5 it's 5. It is 30 square units. Okay, so that is this one where we deal with a polygon of 4 sides, in this case a rectangle and a square, these two special quadrilateral. Let's move to another two-dimensional figure, which is called circle, and you notice here I have several pictures and several formula. The first one is the circumference, which means you go around the circle like the perimeter, and that is 2 pi, and you notice this r stands for this r, which is the radius. Okay. Okay. Area, well, if you remember, area means what is inside. You see I shaded, it's pi r square. Again, radius, that's for the radius. But sometimes when you have the diameter, you can use a special formula for the circumference, pi d. For the area, you have no choice. You have to do pi r square, but first of all, find the radius by dividing the diameter by 2. You'll see that in my next example. Here, find the area and the circumference of each circle. Let's start with A, which is on rectangular grid. And you notice we're kind of lucky here. We have the point B here. This is the radius. Sometimes that's not given to you and you really need to find out. Again, how long is this radius? If you in your mind you're gonna say, hey, this guy is gonna use Pythagorean theorem, that's exactly what I'm gonna do. A square plus B square equals C square. In this case, A and B, both of them are 2. 2 square plus 2 square equals C square. And then we have 4 plus 4 equals C square, which is the radius. Let me replace it with R here, in fact. I guess we can do that. Radius square. So the radius square will be 8. And the radius itself is going to be square root of 8, which can be simplified as 2 square root of 2. Now we have the radius, so we can find the circumference, which is 2 pi r, and that will be 2 pi times the radius. Let's use this simplified form, 2 square root of 2, and the exact value is going to be 4 pi, right? 2 times 2 is 4 square root of 2. This is the exact value. We need to evaluate this. We need to round it to the nearest tenth. So let's use a calculator. 4 times pi. So now it depends how your calculator works. If you have a pi button, that will be great. It does help a lot. And that will be 4 times pi, like I said, times square root of 2. I end up with 17.77 rounded to the nearest tenth, 17.8. And again, here is going to be units because we talk about circumference. The area will be pi r square, so I think it's here we kind of want to use this r square. It's better, right? We already have it. Pi times 8. The area is going to be 8 pi. This is the exact value. An approximation. Wait, let me write square units. An approximation. Obviously, we need a calculator, and we have 8 times pi, and I end up with 25.1. I round it to the nearest tenth. Square units. And that's it for this part A. For part B, very similar. The only difference, if you notice, mn is given, mn, and that is the diameter. So the diameter is 12. If you remember, when the diameter is given, you want to find the radius, which is half of the diameter. That will be 12 divided by 2, and that will be 6. So now we can move and find the circumference. 2 pi r, 2 pi times 6, that will be 12 pi. That is the exact value. We don't have any unit here, so let's leave it like that. The approximation, we're going to use a calculator. 12 times pi, and that will be 37.7. I round it to the nearest tenth. I'm sorry, 0.7 I said. And that's it for the circumference. We have one more thing on this problem, which is the area. Pi r square, right? If you remember, pi r square. And in this case we have pi times the radius. The radius is 6 square. So that will be, using the order of operation, the exponent for 6 squared will be 36 pi. That is the exact value. You want an approximation, of course, you're going to use a calculator. 36 times pi. That will be 113.1 if you round it to the nearest tenth. And that is for this two-dimensional shape called circle. In the sometimes you have a coordinate grid, and in order to find the perimeter in the area, you need to sketch it. So let's take a look on A. We have point A, 1 and 1 right here. Point B, 1 and 7 right here. So this is one side of this polygon. Then we have 6 and 1 as the point for C. And now we do see the polygon, and is something that we discuss about, but the only thing, we plot the points. You have to 1, 2, 3, 4, 5, 6. This is 6. 1, 2, 3, 4, 5. This is 5. We're gonna need this for finding this BC by using Pythagorean theorem, the hypotenuse, right? A squared plus B squared equals C squared. So we're gonna have 6 squared plus 5 squared equal C squared. 36 plus 25 equals C squared. That will be 61 equals C squared. So BC will be square root of 61. So now we can find the perimeter. If you remember the perimeter, we add all these sides. We have 5, we have 6, and we have this square root of 61. So the perimeter will be 5 plus 6, 11 plus square root of 61. This is the exact answer, units. If you want an approximation, is 11 plus the square root of 61, 18.8 rounded to the nearest tenth. One more thing, area is, I think, a lot easier. It's 1/2, remember that, times the base, which in this case can be 5 or 6, times the height, which we can switch it 5 or 6. Either way, we get the same answer. 5 times 6, 30, divided by 2, 15 square units. So again, in problem like this, you want to sketch the shape. It helps you. Maybe it's an easy one like this. I mean, at least for the area. Let's go to part B, where we have to find the perimeter of this figure, and we're gonna plot the points. B, 1 and 1. R, 1 and 5. S, 5 and 5. And T, 5 and 1. Okay, I think this is a nice shape, not too much stress, I think. This is a square. 1, 2, 3, 4. Each side is 4. Notice it is a square. So the perimeter will be 4 times 4. 4. The first 4 because we have 4 sides, and the second 4 because we have a length of 4. So that will be 16 units. What about the area? And this area is going to be side square, which is this 4 square, and we're going to end up with 16 also, but I want you to be careful. This is not the same 16 like the perimeter. This is square units, and in fact, if you count this square inside, you will notice 1, 2, 3, 4, 5. We have 16 square. That is the meaning in this case for this problem. Composite figure. You may end up working with composite figure because guess what? You are not going to have only those basic two-dimensional figure like in this case. And in this case, we can break it into basic figures. And you have choices here. Let's say you're going to do this way. And that is a rectangle. You know, in fact, let's find the perimeter first. Let's see if we can. And for that reason, you want to start from one point. I guess I'm going to start from this point C. Now, we could have started for A, but let's start from C because you'll see what I'm doing now. So if I go down on C, I go to B here and I see this 6. This is the first guy I'm going to put here. plus. From B I go to A. I see this 8. So I'm going around the figure. Plus these 4. Plus I'm going this way, right, to E. This is 5. So these are the numbers that are given. Now we have a problem, or maybe not. How much is this guy? And for that reason you have to look to this 6 and this 4, and 6 minus 4 is 2. So that's the way you're gonna find that missing segment. So plus 2. Very similar I'm gonna do for the last one, the one that goes from D to C and close the polygon. And that one will be, if you take a look, 8 minus 5. 8 minus 5, that would be 3. So add all these numbers now. 6 plus 8, 14, 18, 23, 25, 28. We don't have any units, so we're gonna keep it as a regular number. This is the perimeter. Okay, go around. What about the area? Remember, area is what is inside, and for that reason we're gonna break it into shapes. This is a rectangle, right? The blue one here is a rectangle. And how much is the area of this rectangle? I'm gonna call it A1. Is length times width. 4. That is 32. So the area of the first rectangle is 32 square units. But we have another one, right? We have this guy on top. Rectangle, maybe it's a square, no, it's a rectangle. And you notice this is 3, this is 2. So again, length times width for the second one, and that will be 2 times 3. So that will be 6. So what else do you think we need to do with these two numbers? In this case, we just have to add them. The area of this composite shape is going to be nothing else than you add these two areas. It's going to be 32 plus 6, and that will be 38 square units. We don't have a units, but let's use like this. Okay. Very similar for this example, where we have to find the shaded area. So in this case, it's very important to get an idea of what you need to do. For the shaded area, I'm gonna put it here. The simplest way to do it is to look to this big rectangle. So I'm gonna say area of the rectangle. And from that one, you subtract from this guy, you subtract this guy, area of the triangle. Okay, so we need to find these two guys. So let's start with the area of the rectangle first. In this rectangle is in the rectangular grid, we can count 1, 2, 3, 4, 5, 6, 7. And let's start with the length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The length is 12. And the width is 1, 2, 3, 4, 5, 6, 7. 12 times 7. And that is 84 square units. But what about the triangle? It's very interesting. The triangle is not that bad to find the area. Okay, if you remember, it's 1 over 2 times the base times the height of this triangle. Okay, so in this case we have 1 over 2. The best way to get the base is look to this guy. This is the base. 1, 2, 3, 4, 5, 6. Okay, 6 units from, or you can see from -3 to positive 3 are 6 units. You don't really have to count. Times, now what is the height? The height is this segment that is perpendicular on the base. Count 1, 2, 3 units. So we have 1/2 times 6 times 3, that will be 9 square units. And like I said, we have to do one more thing, which is to subtract these two guys. Area of the rectangle is 84 shaded, right, minus 9, and the area of the shaded region will be 84 minus 9, 75 square units. Another application of these two-dimensional figures that we talk about, the basic one, we look at here a real life application. Jack wants to improve his coffee shop sign shown below, and Jack wants to add on part A a trim around the sign. How much trim should Jack buy? Rather than answer to the nearest foot. So in fact, what they're talking about in part A is about the perimeter, right? Because trim goes around. And let me say we start from here. Let's start from here. That will be 3 plus this will be 4. Now Jack is gonna need to put trim down here where is 13 feet. He's gonna need to put trim here, and this piece here is the same with the other one on the other side is 4. Then he's gonna have to put trim here, that will be 3. Again, we can see that here, and we start with these 3, right? Now the only thing we need to work a little bit in this case is this half of the circumference of this circle. We have a semicircle, how it's called. But the question is, how much is the diameter of this guy? Or the radius, in fact. This is the diameter, right? And that diameter will be nothing else than this 13 minus these 2 3's. So 13 minus 3 minus 3, and that will be 7. That is how much the diameter is. The radius will be half of that, 7 over 2, or 3.5. Let's use this way. So now we can find the circumference, and that will be 2 pi r, and probably I should have used that diameter. In fact, I have 2 times pi times 3.5, and that will be 7 pi. This is the whole circumference, but here we have only half. Remember what I said, it's only half. So the next thing I'm going to do, I'm going to divide that by 2. I'm going to say, hey, that piece is just 7 pi over 2, or 3.5 pi. Okay, so we can go down here and we're gonna get an exact value. We're gonna add these numbers, 3 plus 4, 7, 20, 27 plus 3.5 pi. That will be the exact value. The next thing I'm gonna do is just evaluate, grab a calculator, and we have 27 plus 3.5 times pi, and that would be 37 point, round to the nearest phone, that would be 38. So Jack needs 38 feet of trims around for his coffee shop sign. And this is part A. Let's go to part B. Hopefully I have enough space. I think we do. Jack wants also to cover the sign with a sealer. How much area needs to be covered? So I think this is a keyword. We know now what we need to do. We need to find the area of this composite shape. And we have a rectangle, the red one. So let me change the color to be consistent. This one, ladies and gentlemen, I'm going again on top. This is a rectangle, and that is 13, the length is 13, the width is 4, 13 times 4, that will be 52 square feet. But we have, what else here? We have half of a circle, right? Remember, we have these, I use this blue, half of the circle. So how do I find the area of that guy? The area of the circle, it's pi r squared, pi times the radius is 3.5 square. So let's see how much that is. 3.5 square, that will be 12.25 pi square feet. The last thing I'm gonna do is add these two guys. So the area of this coffee shop will be this 52, the area of the rectangle, plus this 12.25 pi. This is the exact answer, in case you need it. And let's do an estimation, round your answer to the nearest square foot. So we calculator, and we have 52 plus 12.25 times pi, and that will be 90, round it to the nearest foot, 90 square feet. Okay, this is the area that jug needs to cover in this case. Okay. And my last example in this lesson is a very interesting one. We see here a polygon 4 sides, and we need to find the area of the figure below, right? What is the area? So we don't really have a formula for this guy, and in fact, sometimes when you are a rectangular grid, you better think about a different choice. If you notice, I'm drawing another two-dimensional shape that kind of goes around the given one. Okay, the points of the original shape are on the side of this rectangle. 1, 2, 3, 4, 5. This is 5. 1, 2, 3, 4, 5, 6, 7. This big rectangle, the area is 7 times 5 length times width, and that will be 35 square units, right? And now the next thing I'm gonna do is to find the area of those triangle that goes here, like for example this one. And this one is 1, 2, 3, 4. Again, the area of the rectangle is 1/2 times the base 4 and this height of 3. 1, 2, 3. Let's say this is 4, this is 3. That will be 12 divided by 2, that would be 6. Well, a very similar approach we're gonna do for this guy. Okay, this is 1, 2, 3, 4. 1, 2, 3, 4, again 4 here, and this is 1, and that will be 1/2 times 4 times 1. 4 times 1 is 4, divided by 2 is 2. Do we have another one that we can do the same thing? Yeah, this guy here. Now, I want you not to get confused about that 5. That is the 5 that helps us to find the area of the rectangle that goes around of our shape. And this one is 1, 2, 3, 4, 4. This is 1. Oh, we do have this guy exactly on top, so it's going to be the same thing. A3, A sub 3, let me go like that. 1/2 times 4 times 1 is the same 2. Okay, and we have one more. We have this guy. Let's count. Again, I'm going to erase this 7. We don't need it anymore. I don't want you to get confused. That will be 1, 2, 3, 4, 5, 6. This is 6. This is 1. So that A4, A sub 4 to be more correct, is going to be 1 over 2 times 6 times 1, and that will be 3. So now the last thing you want to do here for finding the area of the shape we're looking for is what? From the area of the rectangle, which is 35, you want to subtract all these numbers. The area of the first triangle, 6, second triangle, 2, third triangle, 2, fourth triangle, 3. So that will be 35 minus 6, 29 minus 2, 27, 25 minus 4, minus 3, 25 minus 3 is 22. Let me double check this math. Let me put the units here, square units. Let me double check this math. 35 minus 6 minus 2 minus 2 minus 3, and that is 22. I was correct. And that's it for today's lesson. If you enjoyed this lesson, don't forget to click the like button and come back on C Squared for more help. Thank you.